Okay, so solving trigonometric equations is very, very much the same as solving the trigonometric equations with degrees instead of radians. One way you can do it is you can just convert everything to degrees first, or solve them using degree first and convert everything back to radians. Or alternatively, you can just use radians. So what we'll be doing is we'll just be using radians, but remember at all times you can just solve these using degrees and then convert back to radians. So first of all, we've got cos x is equal to root 3 on 2, and then we've got cot x of 1 on 3. So we're going to start off by looking at cos x of root 3 on 2. Now, we know that cos of x is equal to root 3 on 2 when it is in the first quadrant. Okay? And when we're looking at cos root 3 on 2, okay, we're thinking back to our exact triangles. So our root 3, our 1, and our 2, and it's our 60 degree and our 30 degree triangles. So looking at this one in specifically, we want root 3 on 2, okay? So which angle gives me root 3 on 2 in this case? Well, it's when cos is 30 degrees. So root 3 and 2. So cos of x is equal to 30 degrees. So this is converting it. Oh, sorry. Cos of x. So let me rephrase it. Cos of x is equal to root 3 on 2 when x is equal to 30 degrees. And that's in degrees. And to change it to radians, we just convert it. So x is equal to, that's a square root, not a pi. It should be pi on 6. And that's it. Okay? So pi on 6 is with that one. Now cot is a little bit different. Okay? So cot x is equal to a third. So you can also use your calculator to solve these ones too. So cot of x is equal to a third. So it's the same as saying 1 on tan of x is equal to 1 on 3, which is the same as tan, I don't know what happened with my hand then, which is the same as saying that tan of x is equal to 3 by just flipping or doing the reciprocals of both sides. Okay, to find the x then, we're going to take the tan inverse of both sides, okay, and so x is going to give us, and we can just plug it straight into our calculator. So tan inverse of 3, and that's equal to 1.249. And that's it, correct to 5 significant figures. Okay, so with that one, obviously it's not an exact value because it is a bit ridiculous, and because we don't know what tan of 3 is, we can just use it in our calculator to get an answer for that one. Okay, so let's go to some more general some more general trigonometric equations. So the first one here, we've got sine x is equal to a half, or negative a half, when between 0 and 2 pi. So we need to go back to our exact values on our unit circle. So looking at this one here, we need to go back to all stations to central. And we need to think about, well, when is sine equal to a negative number? And it's only equal to a negative number in the third and fourth quadrant. So between pi and pi on, or 3 pi on 2, and 3 pi on 2 and 2 pi. Okay, so it's somewhere in those two there. So now we need to think back to the related acute angle. So sine of x is equal to negative 1/2. So that means that the acute angle whose sine is half. Okay, so we're thinking, well, when is sine of the positive equal to a half? Okay, when is the sine positive a half equal to x? Oh, sorry, let me rephrase that. When is sine of x equal to 1 positive half? So thinking back to the acute angles. So going back over to the exact values. So let's go back to I'm going to go back to my triangles, which were here. Okay, so a half, we're thinking this one here, down here. So this triangle here. So half is, so we want sine, so opposite over half. So it's over hypotenuse, sorry. So it's the 30 degrees, so it's pi on 6 for that one too. That's not what I wanted this one. So pi on 6 using that one there. Okay, so sine of x, so x must be equal to, so it's pi on 6 in that case. So pi on 6 in the third and the fourth column. So pi on 6 is the same as 30 degrees. Okay, so 30 degrees is here. So pi on 6 in the fourth quadrant is coming from here. And remember, we always measure from the horizontal down or up. So my pi on 6 is coming that way from here. Okay, so I need to work out, well, if it's 2 pi and I'm subtracting pi on 6 to get back down there. So it's the same as 6 pi on 6 minus pi on 6. So that means that x must be equal to, what is it? It's pi on 6, so it's 5 pi on 6. Or x must be equal to, and going from this one over here, so it's pi plus pi on 6, so 3 pi on, oh sorry, this should be 12 pi on 6, so that one, this one's 6 pi on 6 over here, 6 pi on 6, because that's the same as a pi, plus pi on 6, okay, so that one's 7 pi on 6, sorry, not 5 pi, and then this one over here is 12 pi on 6, because 2 pi is equal to 12 pi on 6, minus just a single pi on 6, so that's 11 pi on 6. So 11 pi on 6. So if we put in that into our calculator, so if we go sine of, where is it now? Sine of pi on 11 pi on 6, let's say, so 11 pi on 6, we should get that this is equal to negative a half, and we do. So there you go. So it's just sort of like reverse engineering. So if we put the other one in as well, so 6, and I think that one was 7 pi on 6, we also get negative half, so there's the two values there. Okay, so that's part A. Now part B's sine 3x is equal to a half. Okay, so part B, sine of 3x is equal to a half, like that. Okay, so sine of 3x like that. So, and we want to look for where it is between 0 and 2 pi. So to find the domain for 3x, we simply multiply the condition by 3. So, for example, sine of 3x, because we want sine of x between 0 and 2 pi, sine of 3x, we're looking between 0, 3x, and 6 pi. Okay, so if we essentially multiply that by 3 and that by 3, so all these by 3, we get our new domain. So sine 3 of x of a half is in those domains, like that. Okay, so working with the diagram that we made from before, so this one up here. So again, we're looking for halves, okay? So a half again. So if we think about a half, we're thinking of a half is pi on 3, I think. No, sine of a half is 60 degrees, okay? So pi on 6s. So we're working with our pi on 6s again. Okay, so whereabouts is pi on 6 positive? Okay, so this time it's positive. Well, we already know where one spot it's positive. It's up here, so it's pi on 6. We also know it's one over here. So it's minus pi on 6 in that regards. So if this is 6 pi on 6 over here, so 6 pi on 6 over there, that's disgusting. So it's 6 pi on 6 over here. And we're taking away pi on 6, and that means that value up here is 5 pi on 6. So our two values where sine is positive is, now this is between 0 and 6 pi. So it's it's equal to, or I should say, I can't even speak. So 3x is equal to, so back up here, it's pi on 6 and 5 pi on 6. Now that's only between 0 and 2 pi, but we want between 0 and 6 pi. So we're just essentially going to be multiplying these by 2 pi. So the first one's going to, by 2 each time. So pi on 6 times 2 is just, pi on 6 times 2 rotate, so like a whole rotation. So we're adding 2, I should say. So if you think about it, here's your circle here. Okay, if pi on 6 is here, and 2 pi is 1 revolution. Okay, so we're adding an extra little bit, which is so it's going to be 2 pi plus pi on 6. Okay, so it's going to be 12 pi on 6 plus pi on 6. That's 13 pi on 6. Okay. And then we're just going to do that twice to do 2 revolutions because we want, so remember this is 3 lots of 2 pi, so 3 revolutions. So 3 revolutions of that, so 13 pi on 6. So first one, adding 12 pi on 6 to the second one, we get 17 pi on 6. And then doing it again for the third one. So adding 12 pi to both, 12 pi on 6 to both, we get 25 pi on 6 and 29 pi on 6. So that's where 3x is equal to that in the domain between 0 and 6 pi. So that means that x, well, we just divide everything by 3. So pi on 6 divided by 3 is the same as times equal by 1/3. So pi on 18. Okay, and then 5 pi on 18, 13 pi on 18, 17 pi on 18. So you'll notice with these ones, these are all between 0 and 1 pi. And then for these ones, we've got 25 pi on 18 and 29 pi on 18, like that. So just a bit over 1 pi. Divided by 3. 6, 12, 18. Yeah. Okay, cool. So those are our values for when that is true. Okay, so we can check that as well. Okay. So on our calculator, if we put in, sine of 3 lots of any of these, we should get our value of, I believe it was half. So let's just try one for example. So let's try 25. So 25 pi on 18. Close it off, and there you go. It's a half as well. So it's just basically expanding the domain and then reducing it back down once you get your values. So that's part B. Now part C says it's equal to -1/3. Okay. So, and I believe that was cos. So cos x is equal to -1/3. I might do it over here. So cos x is equal to -1/3 between 0 and 2 pi. So similar to before, we want to get a value when it's, or it's just a -1/3, okay? So it's not too tricky before, but it's just a matter of finding what our value was. Now, because before when we looked at the other ones, other exact triangles, there's no point where we can get a third on these, okay? So we can't use these exact triangles here to get our third because there is no exact triangle that will give us our third like that. Come to that one in a moment. So we're going to have to use our calculator in Radians mode to do this one. Like, we'll have to use this one. Okay? So let's start off by thinking, well, where is cos of x negative? So cos of x is negative in the second and third quadrant. So we're going to be essentially adding pi and subtracting pi. So in other words, okay, we can work out what the acute angle is. So when cos x is equal to 1/3, which is between 0 and pi on 2, or in the first quadrant. Okay, and then to do the negative with the second and third, so for negative a third, we need quadrant 2 and quadrant 3. So that's a third. So we need quadrant 2 and quadrant 3. So we're essentially going to subtract pi and add pi to get there. So let's use our calculator to work out what that's going to be. So inverse cos, so x is equal to cos negative 1 of a third. So x is equal to 1.23 radians. Now for our radians, we can add and subtract pi from both of these. So if x is equal to a third in our quadrant 1, okay, that's what it's equal to in quadrant 1. And for quadrant 2, so cos of x is equal to negative a third. So that's the same as pi minus 1.23, which is this value here. Okay, because if you think about it, in our circle, okay, so back over here, our circle, we're starting at this point here, okay, and we're subtracting what we need to get to our value for this one. And of course, for the other way, we're going to be adding on the pi value to get over here, because it's essentially saying it's this angle here plus the 180, or the other one is, so like it's from here, so it's 180 minus that little bit there. Okay, so back over here, so for the quadrant 2, it's pi minus 1.23, so we can literally just put this straight into our calculator. So pi minus our answer, which is then 1.91. And for quadrant 3, so cos of x, again, is equal to negative 1/3, because quadrant 3 it works. So it's equal to pi plus 1.23. And so it's equal to, so we hit that, and we go shift pi plus our answer from before, and we get 4.373, let's just say. So with that being said, that's how we do those ones. So when it's a little bit trickier on those. So for this one, the trick is calculator, okay, because we don't know the exact values. Okay, multiply domain by 3, and of course if there's a fraction there, you just divide it by that. And this one is exact values. Okay, we're going to have a look at a few more examples, just a couple more, okay? And like these ones here, okay? And these are some trigonometric equations reducible to quadratics, okay? And so what we mean by that is we can do some substitution or some methods to work out what these ones are. So in the first case, we've got cos squared of x is equal to root 3 on 2. So think of it like the same as saying I've got cos of x all squared equal to 3 on 4. So how would we solve this? Well, we would take the square root of both sides, and that would end us with plus or minus the square root of 3 on the square root of 2, which 4, which is 2. Now, when is cos of x equal to root 3 on 2? Well, if we go back to our exact triangles, and we're going to keep going back to these exact triangles, root 3 on 2 and cos, so it's going to be adjacent and hypotenuse. So root 3 on 2 is when it's 30 degrees, or pi on 6. And I don't want you, I want you. So pi on 6. This one here. So cos of x, or x I should say, is then, so x must be equal to positive pi on 6, or x is equal to negative pi on 6. And we can test that too by putting it into this. So if we put cos of pi on 6 into this, so pi on 6, okay, that should give us root 3 on 2, because that's the same as if I was to square it. So squaring it, that would give me 3 on 4, which is what the initial question is asking. But of course, if I put in the negative pi on 6, it should also give me 3 and 4 too, because again, I'm squaring that solution. And when I square a solution, it's going to give me both the positive values. Okay, so that's what that part is referring to. So we can do that quite easily. Number 2, though, is a little bit trickier. So part B, what we're going to have to do is we're going to have to do some substitution. So we've got 2 sine square x minus sine x minus 1 is equal to 0. Okay. So what we're going to do is we're going to say, well, let's let u be equal to sine of x. Okay, so by doing that, this allows us to write this as 2u squared minus u minus 1 is equal to 0. And then this just becomes a quadratic that we know how to solve. So in this case, so 2u squared minus u minus 1. So I'm thinking of two numbers that multiply to give the 2, but add to give 1. Add to give, yeah, no, that's right. Multiply to give negative 2 and add to give 1, negative 1. So minus 2 and 1 are my two that I'm looking for. So I can rewrite this as 2u squared minus 2u plus u minus 1 is equal to 0. Taking the common factor out, we get 2u on the outside, and it's u minus 1 here, plus, 1 lots of u minus 1 is equal to 0. Common factor is u minus 1, so u minus 1 comes out. That leaves us with 2u plus 1 here, which is equal to 0. Okay, what we can do now is we can substitute both of these, or we can say now that we want when u is equal to 1, and when u, because we want to find when values of these are equal to 0, or when u is equal to half. Now resubstituting, so resub, u is equal to sine of x into these, and we get sine of x is equal to 1, and sine of x is equal to a half. So the question becomes, well, when is sine of x equal to 1? Okay, so sine of x is equal to 1 at 90 degrees, which is the same as pi on 2, so x must be equal to pi on 2. And we can verify that by substituting it in. So sine of pi on 2, there we go, it's 1, which is the value we wanted. And our other value, so when is sine equal to negative half? Well, it's very similar to problem to over here, on the other side, I should say. So it's negative half, so thinking again, go to exact values. It's negative in third and fourth quadrant. Sine is also, nope, sorry. Yeah, sorry, third and fourth quadrant. Okay, so a half is, a half is, okay, I'm gonna have to go back to the exact values for these ones. So my half is over in this triangle here, and it's, I want 1 on 2, so 30 degrees. So pi on 6, I need to stop doing that. So pi on 6, so sine is pi on 6 in this direction, and pi on 6 back in that direction. So this is going to be when sine is equal to 6 pi on 6, so it's 7 pi on 6, so pi on 6 plus, so I should write up here, pi plus pi on 6, and 2 pi minus pi on 6, which is 11 pi on 6, like that. Now, of course, we can verify that again by using our calculator and substituting it into that quadratic, the original quadratic. So we've got 2 sine, and we will try, let's try the 11 pi on 6 for this one. We'll just try one of them. So 11 pi on 6, so we're going to go sine of 11 pi on 6 squared minus sine of 11 pi on 6. And this should be equal to 0 when I subtract 1 from it. And there you go. So that's solving trigonometric equations, which is nice and fun. Of course, it's just applying trigonometry with equations, solving how we know how to do and what we've been doing for a very long time. So with that being said, that's going to be the end of this video, and I will talk to you guys in the next one.